Hi, I'm Jason Kennedy, and I teach 3D animation at Auckland University of Technology. I'm also the managing director of K. Amani Fine Jeweler in Auckland, New Zealand, where my wife and I design custom jewelry for our clients using a combination of the software programs Rhino and ZBrush. In this series of lessons, I'm going to walk you through my design process as I create a dragon head ring in ZBrush that I will then 3D print and cast in sterling silver. This lesson is designed to get you up to speed on some of the design considerations you need to make when creating jewelry that is intended to be worn. And ultimately, in 3D, we have the ability to create amazing designs that look really great on screen, but many of those designs would simply be a nightmare to try to make in real life. I'll point out some of those pitfalls as we go along. Now, the concept that I'm working from was designed as a quick sketch by Sanjana Bejnath, who's a great illustrator and colleague of mine at Auckland University of Technology, and I encourage you to check out her work at sanjanasart.com. So before we begin modeling our ring, I want to make a caveat. Normally, I would actually be modeling the base of this ring in a program called Rhino, which is a NURBS-based modeling program, and specifically using a plugin for Rhino called Rhino Gold. This plugin helps jewelers to basically have a whole bunch of automated building processes that just saves a bunch of time, and it does a lot of the work for you in many ways. So I just really want to quickly show you what I would do in Rhino Gold, and then we're going to try to replicate that in Maya. In Rhino Gold, I'm not going to go over how to use Rhino. It's not a software that I typically think many readers of 3D World are going to necessarily be familiar with. But it's important to just see how this process works. So the plugin itself creates a ring wizard, essentially, where you can choose essentially what size ring you want to create. In my case, I know that my ring size is a size S. Now this is British sizing because I'm in New Zealand. We use British sizing here. If you are in the US, you might be using a numerical system. If you are in Europe, you will be using a numerical system too, but it's a different numerical system. And if you're in Japan, you have a Japanese numerical system. So depending on where you are in the world, that's the kind of sizing gauges that you would want to look for. And really, it's not so difficult to figure this out because you can just simply go online and basically search for something like ring size diameter in Google, and you'll be able to pull up a list of different ring sizes. If you go to a local jeweler, for instance, you'll be able to find out what is your ring size. But there are little ring size little ring size measurers, for example. We have one on our website as well, where you can essentially just find out your ring size from a current ring you already own, or just based on sort of hand size in general. So it all works out really nicely. You can easily figure out your ring size. And in my case, like I said, I'm going to be working in the British units, and my ring size is S. So I would come down here and find S, and it tells me what the diameter here is in millimeters. And basically, when we're working in jewelry, because we're working in small things, we are working in millimeters. So the diameter is 19.1, and I would also normally create this with a particular width. Now, how wide is a ring meant to be? Well, that really is up to you. This is going to be basically a men's ring. Men's rings typically are in the range of 5 millimeters wide or wider. I think for the purposes of making this dragon head, we need a little bit of a width, a little bit of a base to work from, so that the head has something to stick onto. So I'm going to create a ring that is 6 millimeters wide, and automatically generates that here for me. And I also want to determine what is the profile going to be of the ring itself, because that is going to be the shape that we get from the interior circle and the shape that is generated from that. So right now, the default profile shape is this sort of slightly domed shape, but really what I want to create is a true half dome, which is what this shape is here. And now that creates a flat on the bottom and a half dome shape at the top. I'll also probably just push the height up of that a little bit more. That's going to make this stick up just a little bit more than we had before. And normally from this I would just say OK, and I would generate the NURBS geometry and if I was to take this into ZBrush from here, I could export this out as an STL or as an OBJ and bring it in that way. Now what I'm going to do is actually model this in Maya, because I think that's going to be perhaps a bit more useful to the readers of 3D World, and I will give you a little bit of stuff to make this a bit easier for you. So I'm just going to close out of this real quick and pop over into Maya. Now, the first thing we need to do when we get into Maya is to make sure that our units are set up appropriately, because Maya's default units are set to centimeters, and that's going to be a bit too big for us. So I'm going to come down into my settings. Just click on the little animation preferences button next to the auto key button, and I'm going to change my scene settings from centimeters to millimeters, and that's going to make my grid look a lot smaller. That's about the only change we really need to make at this stage. So I'll just save that, and now if I were to come into my ortho views, I would be able to see, let's see, maybe turn on the grid for this one, be able to see a tick or 2 lines crossing for every 1 millimeter of measurement. All right. So what I said back in Rhino Gold was that the ring that we were creating at size S was 19.1 millimeters in diameter, I believe. Yep, 19.1. We are going to try to replicate that here in Maya. It's very simple to do. So I'm just going to pop on over back into Maya here, and I'm going to create a NURBS primitive. I'll get rid of interactive creation because I hate that, which was not the default. So I'm going to create a circle, and I'll go to the option box. This way I can type in exactly what I want, and you can kind of see that I've already done this before. So I'm just going to really reset the settings real quick. Basically, we aren't dealing with diameter here, we're dealing with the radius. So the radius is half of the diameter. 19.1 divided by 2 is 9.55, so that will give us the proper radius. I also want this to be created down the z-axis, so that way it will appear here in the front view. And I'm going to make sure that the number of sections is set to about 50, and that way it's just going to create a nice smooth circle to work from. Otherwise it will look a bit tessellated or nickeled. So with that, I'm just going to hit create, and now we have our circle. Okay. Might make that a little bit darker there so it's easier to see. I'm keeping the grid lines on so that it's basically easier to understand how accurate I need to be, or I should say how precise I need to be. When you're dealing with jewelry, when you're dealing with something that you are intending to 3D print and that you are intending for somebody to wear, you have to be really precise. And that's a challenge for me, really, because as an organic modeler, I tend to be a bit, loose. I obviously will model it to an image plane or to a concept, but at the same time, I have a lot of freedom. And unfortunately, even a small amount of measurement change on a ring, for instance, may mean that it's either too big or too small to wear, or that it could cause other problems when you are trying to actually 3D print and or cast it later on into a metal of your choice. So we have to be really, really specific and really, really careful. This is why generally people will use a program like Rhino instead of Maya, because Rhino gives, in my opinion, a lot better precision. It's a lot easier to be precise in Rhino than it is in Maya. But using a few just simple workarounds of specific measurements, for example, like what we just did now, in Maya, we can still get the same kind of results. It just might be a little bit more difficult, that's all. So we are going to construct this shape using NURBS. It's going to be our simplest way to do this. It's very similar to what Rhino would have done in the background when we were using that ring wizard. The shape that we're going to use for our profile is quite specific, and if you're not familiar with that shape, I don't expect you to draw it correctly. So what I'm going to do is I'm going to provide you with an image that you can work from to make life a lot easier. So I'm just going to go into my side view. Come in here. Like I said, I'm going to leave the grid lines on because they're going to be useful to us here in a moment. I'll show you why. And I'm going to go to View, Image Plane, and Import Image. So I have created here just a drawing in Photoshop of what that half dome profile looks like. And we bring that in, and it's really, really large. Now, ultimately, the shape itself, or this line here, I should say, this horizontal line here, should be 6 millimeters in width. Because as I had created this ring before, you might recall that I had set our width parameter to 6. And that's basically why we want to do that. That will create a ring that has the appropriate width. Okay, so I'm going to come down here in my image plane shape and change my width down to 6. And that's going to be pretty darn close. We're going to actually have a look here to see, is it exactly 6? It's not exactly 6 because I have a little bit of room on the sides here, so I need to widen that out slightly. Just so it's easier to see, I'm going to push this back in Z. So it's going to hit Control, not Z, sorry, X, on the wrong axis. Control middle mouse button, I'm just going to push it back, and that way it's going to sit behind the grid lines, and it'll be easier for me to make these adjustments. So I'm just going to change my width here very subtly until we get to about 6 millimeters on either side. That looks pretty good. So that looks like 6.170 is going to get us close. That's close enough for our purposes. If we're off ever so slightly in this dimension, it's not a big deal. Okay, what you will notice is the height here. So let me just put this up on the x-axis so I can show you what what I'm meaning by this. I'm just going to move this up in y until it sits basically right there on the axis line. Okay. And one thing to notice is that this is actually 1.5 units tall. And again, that comes back to when I was setting up the height value here, we set this to 1.5. Okay, that's just trying to show you how all these parameters relate to each other. Now, as I go about this, I'm going to create a curve here using the CV curve tool. And I'm just going to go ahead and turn down the alpha gain here a little bit. I just need to see that in the background, but I don't need it to be so dark. So I'm going to go into create CV curve tool. Just some basic settings on there. It's cubic, and yeah, that's all I need to really worry about. So I'm going to start up at the top here, and just going to place a few CV points around the curve. They don't need to be 100% precise to begin with. And as I get closer and closer down to where this curve is starting to change direction into this 90-degree angle, I need to have a higher concentration of points essentially to make this rapid change convincingly. It's going to be slightly round. It's not going to be perfectly hard, but that's okay. We don't necessarily need it to be perfectly hard. And I'm just going to bring this over. It's close enough if I get right onto the grid line. I'm not 100% concerned about it snapping right onto the grid line because we're going to basically end up blending this a little bit with some of our later functions. Okay, so I'm just going to go in here and I'm going to start to make some adjustments to this curve. I'm just going to right click on the curve and go to the control vertices and just start moving these individual CV points around so that we get this curve sitting a bit more nicely on the drawing. And if this is something that you're already familiar with, I apologize for trying to make it so many steps, but there might be some readers who aren't all that familiar with working with NURBS. I know NURBS was for a long time something that I was not much of a modeler using, and still to this day, I'm much more confident as a polygon modeler. So bear with me as I do this. Okay. Why am I only doing half of this? Well, I really want both sides to be basically identical. And if I try to do this on both sides, I'm likely not going to match these CV points up exactly. So I'm just going to set this back to object mode. And I am going to, I'll leave the image plane on for now. I'm going to duplicate this. So I'm just going to hit Control D to duplicate. Oops, sorry, that was Control S. Control D, there we go. Now, if we go into the outliner, we have two curves. All right, curve 2 is sitting on top. And I'm just going to mirror this, basically. And to mirror it, I am going to scale it across -1 in Z. Okay, so now we have two copies of this curve. You see them here. There we go. And to attach this curve together, What I will need to do, well, let's just take a look. Let's see what happens if we just try to attach this curve as it is. So if we go into our surfaces and we go to Edit Curves, Attach Curves, right, and we just say, let's just keep the options as they are, then do we get the result that we want? Well, it doesn't look too bad. So let's see what we get here. If I go into the control vertices, take a look here, that looks pretty good. All right, so that's blended there. And up here at the top, however, we'll notice that the top basically is left unblended or unconnected, essentially. So that is a little bit of a problem. All right. Sometimes what you'll find, and I thought it might happen in this case, but it didn't. Sometimes what you'll find is that you actually need to go ahead and reverse the curve direction here. So that might be going down to reverse curve direction. And the reason for that is sometimes when you make this blend or this connection, you end up having this curve up here connecting down here, and this one trying to connect over here instead of connecting at the points that we want them to. If that's the case, then you just need to use the reverse curve direction. In this case, it seems to be fine. So we'll just use, repeat what we had done before. Blend, cool. Now, I'm just going to move this up really quick so that it kind of sits on its own, so it's easier to see. How do we resolve this issue here? Well, this should hopefully be pretty simple. I'm just going to go ahead and click on the curve, and we're going to go into Edit Curves, Open Close Curves. And we'll just try the default options. Did that work? Well, it looks like it did. Now we have a closed curve, but we have created a few more CVs than we had before, and you can see that these CVs actually overlap each other, which is not 100% great. So let's just undo that, and we'll try that again using Blend. Okay, well that didn't work. So we're just going to have to deal with the fact that we have that we're preserving this shape basically, and to solve that problem, I'm just going to select both of those CVs. I'm going to go into the Scale tool, and I'm just going to switch these around, and that basically will preserve that shape. Okay, I don't think we're going to have any problems with that. Close enough for government work. Okay, so now we have our shape. This should be a fully closed shape, which is good. And I am just going to go ahead and, for now, get rid of this image plane. So come up here, get an image plane visible, just click on it, delete it. And these were the original curves as well. I don't really need those anymore either. Right? So I'm going to go up, and I'm just going to hit the C key, because sitting right here on the y-axis is our the original profile that we did, this one, right? The circle profile. So I want to I want to push up this curve to sit right at the top of the ring profile. So I'm going to hold down the C key for curve snap and just hover that over there. Eventually we'll snap to that curve, and there it is right at the top. Okay, I pushed up as far as it can go. So if we come into the perspective view now, this is sitting exactly at the top. Snapping is so incredibly important when you're working with NURBS. So if you're not familiar with snapping, definitely brush up on that. Okay, so this next step does a lot of work for us. It's really straightforward. I'm just going to click on the profile that we want to extrude around this curve. Then I'm going to click on the actual circle itself. We're going to come up to Surfaces, Extrude, Options. We're going to extrude it as a tube, and we are going to complete this thing as a polygon. We want to output a polygon here. And I would say make sure that that is in fact checked, and we'll just see how this goes. We'll hit apply, and there we go. Look at that. We've made a ring. Very nice. All right, and this ring here is polygonal, which is great. Hit the 3 key just to go into smooth mode. Usually if there are going to be any problems with this, we'll notice that there might be some tearing or whatnot when we go into this smooth preview mode. I don't see any tearing right now, so this one looks like it's pretty good to go. I'm just going to push that back into space there so it sits right on the normal, the axis. And excellent. So this is how we construct just a basic ring shape to work from. Now that I've constructed this, I'm just going to export this out as an OBJ, and I'm going to hold it in my ring inventory. because I'm not going to actually work with this particular geometry right away. I'm going to bring this in at the end, and I'm going to put the dragon head on top of it. For now, in our next step, we're going to go ahead and actually start constructing the dragon head geometry, and we'll worry about scaling issues and stuff like that as we work through it. So for now, what I'm going to do is just export this out, export selection as an OBJ, and I'm just going to take this and I'll export it out as base ring to ZBrush. So usually the way that I just keep track of which way a piece of geometry is meant to go, I'll usually append at the end of it where it's intended to be used, and that way it'll tell me, hey, this is the ring that I should be using. So I export that out. I'll replace that, and that will take us to the end of this lesson, and in the next lesson we'll take a look at how we start constructing the basic geometry of the dragon's head.